Is the audio now is working here? Okay. Yeah. We are still waiting for the people to enter the room. We hope it happens soon. I mean, we're just slowly coming from lunch, and sorry for the delay, everyone.
Who will present first?
I will present first.
Sharing so that we can see if it works.
Okay, I will start sharing that with me. Okay. So let's try to gather the people. Yeah, let's. You can try to make them come in, Javi. Okay. Okay, so thank you. Sorry for the waiting for the remote one. Remote one, we have a lot of people connected, which is really nice for this nice session about the future directions of the 5G KPI project. So I will, as I said this morning, we have prepared this in a workshop format. I will do a brief introduction now that I have prepared with Shell, and then we will continue. So basically, a short recap of the 5G KPI goal. Maybe for the ones who are new in VQuake, could be also an interesting starting point. We created this project in VQuake a few years ago to try to close a bit the gap between the networking research and industry and the QoE and the video, let's say, codec and use case research and industry, we may name. So basically trying to define relevant use cases and study global key aspects for video mobility. And most or a key focus was to identify how to connect the KPIs which are measured in the network with the application level KPIs and basically with the user experience, and ideally to build some open data sets for that purpose. We have addressed all of these topics yet. We don't have closed the topic. We have discussed a bit of ideas in the last years. We also did a technical report for ITUT, but still we have a long way forward, we hope. So we, in the last meeting, tried to discuss the next steps, and this is why we are here. So for a bit of context, in 3GPP framework, you might know that 3GPP works with releases. They try to open a few streams in parallel, and we are in the era of what is named 5G Advanced. So the standard 5G workflows in release 17, and 3GPP is now defining release 19. Still not yet in the 6G era, which will happen around release 21st. Which means that there is still an opportunity to contribute to the future generation of standards, and this is one of the reasons we are here. So to understand where we are, I would have a few words on how QoS and QoE is modeled in 5G network, and there will be wider presentations today. But quite briefly, in 5G networks, and it happens also in other kind of communication networks, quality of service is the part which is actually enforced. So basically, 5G has a way to enforce quality of service end-to-end from the perspective of the mobile network, so including the terminal, the UE, the base station, the GNOT B, and the core. And then it can define like basically traffic pipes, where you can have a priority level, delay budgets, error rate targets, and in some points a guaranteed bit. So this is basically what can be enforced by the network so far, and this is at the core of the standard, kind of well, implemented and up to some point used in the public networks. There are a bit more sophisticated ideas, meaning that the idea of understanding the QoE that's happening in the user equipments is not new. It's something that has been discussed in 3GPP for a long time. And there are actually two methods for this kind of QoE measures to be collected from the user to the network, basically. One involving the AF, meaning the application servers, and one involving directly the user terminal. And I will explain them briefly, and also to have so for you to have a grasp on how 3GPP thinks of quality, let's say. So first of all, these are the kind of metrics which are mostly targeted. They are very related with with specific application architectures. The classical one is this MTSI, which is basically telephony or voice over IP or multimedia over IP using both, this kind of technology. So RTP based, and then we have this kind of metrics which are applied mostly to voice calls. And there's this other set of metrics related to Dash for a reference architecture called 5G Media System, which have also an extension on VR, which is basically a streaming of 360 video using Dash. And these are the kind of metrics that are considered in the standards. And there are two ways to collecting them. This is the first one which was defined. This is the QoE measuring collection framework, which involves a lot of signaling between the core, the base station, and the mobile phone, so that the mobile phone is able to collect the networks and send them to the network, to collect the metrics, send them to the network, and then having all this traffic here and there. And it's not widely used, I would say. Probably not used at all, but very, very limited uses, being optimistic. Mostly because it requires a strong coordination between a lot of different players. So you need like the UE application, then you need the UE operating system, you need the UE hardware, you need the base station hardware, the core software. So there's a lot of players that need to implement small pieces to make these things work. And it's a bit difficult that at the end of the day it's really used, especially if there's like no strong demand from the customers of getting these kind of features. So starting in release 16, so already a couple of releases ago, there has been strong push in 5G to create what they call network exposure, which is basically offering some APIs directly to the core that can be called from the application. So in this case, there's a standard interface defined between the core and the AF, which is the application function, or basically you could think that this is like the application server where we have our streaming server running, or whatever part of the application that we want to have. And then you can get these UA application events, like the ones that I've described before, but also they have defined a few other metrics which might be slightly more related to the QoE, like some ways of at least describing the mean opinion score of what's happening in the application. But there's still something very limited in the Steam to be seen if it's going to be used or not. So what do we have in practice? What we have in practice is that there are two types of players simplifying a bit, but two types of players in the industry. There's huge information mismatch between all these kind of players have. So basically, we have on the one hand, the content and application providers. You can think about, well, we have some of them here. We have Meta, we have Netflix, we have YouTube in the big web, okay? So basically, they know a lot about what's happening in the application. So they have this client, the bandwidth estimation that they use to get the video from the server. They would probably have user analytics, complex context workflow, whatever, and they are handling with a mysterious network which provides them with random bandwidth and random QoS that they don't have any information about. Well, on the other hand, if you are like a network equipment vendor like Nokia or Ericsson, or a network operator like AT&T or Telefonica or NTT, you are on the other side. You know a lot of what's happening in the network. You can know that you have a mobile terminal connected to a specific base station. You can even know what's happening in all the infrastructure. And you are handling, like, simply you're connecting some data producer with some data consumer, which are exchanging encrypted traffic you don't know anything about. So of course, this happens for a number of reasons, but it still shows that there is a way to improve the information that is handled in both sides of the connection, and maybe we can somehow make these two technology stacks work together in a better way. But this doesn't only happen on the industry, it also happens on the research community. So if you look at QoE in papers, the QoE terms in papers from the IEEE Transactional Multimedia, for instance, in papers in journals where typical BQEC researchers will be publishing, you will have this kind of diagrams of factors going here, and there are some technical scores, all the typical graph that you get into these presentations. But if you look for QoE in the communications research world, we do basically have cost functions which are applied to a set of communication problems. And even the type of research, the type of language which is happening there is totally different. So we don't only have a mismatch in terms of what's happening in industry, we also have a bit of lack of understanding between different research communities that should probably cooperate a bit more if we want this thing to work together, okay? And finally, we have a diversity of use cases, which is expanding. So today we have the use cases that we all know about and have been researching a lot. We know the streaming. This is kind of one of the key use cases that we discuss here. We have the video calls that for some reason we don't discuss it too much at BQEC, but this is still a relevant use case. We have the online gaming, also a lot of discussion and a lot of standardization. But there are other use cases that haven't presented here, but they're still not really so well known in the sense of how they're going to be actually applied in practice in the industry. But we discuss especially in our former 5G KPI work item, they will have their own requirements. So somehow we need models that can cover everything. But the problem with the networks is that as of today, the network cannot distinguish which of these use cases is actually running on top. So even if we have this information, we should have a way for the network to actually manage different kind of use cases and still optimize how things work. So altogether, this is the problem that we more or less have identified. There are other like low level missing points and control conditions that I also presented last meeting here in December. So yeah, from a slightly low level perspective, there's some things happening, let's say in the industry, that all these metrics that I presented before, there's no clear way of mapping them to an actual POE value. In general, there's the only hub that we can manage in them is quality of service. So and still there's a very limited interpretation of POE metrics when used in network design. So there are some limitations, a bit more detailed than the ones that I presented before, and also some conditions that we have. That there's no plan so far in 3GPP to change this significantly. Let's say there's been some conversation between 3GPP and the study group 12 of ITU-T to introduce parametric or any kind of monitoring models into ITU standards, but nothing has happened yet. And still there's a practical problem, is that this QE analysis is something that is typically in industry done at network design phase, but not at network monitoring phase, which means that it's something very, very targeted and short time. So somehow there's no strong push from the industry to do this global QE management in general, but there's still this information mismatch which has been identified that can be the driver of our next activities. Okay. Oh, and finally, of course, there's the risk to develop a new model or a new framework that is very fancy, but is still not very widely used. So, recapping a bit what we are trying to do, since last December plenary meeting, we have been having a few 5G KPI meetings to prepare this workshop. So the first thing that we did was identifying the goal. Probably the goal is to develop better quality of service, quality of experience models, and develop a framework to manage the quality of experience in the next generation. This is kind of the North Star, so where we are targeting. Let's see what we can actually do in Beequake, and this is the purpose of the workshop today. So like the two key points is that the current status is this missing visibility between what's happening at the application and content layer and what's happening at the network layer. There's also the decision somehow that we should start by today use cases with an eye of the future use cases. But by today use cases, we should cover more than one to make sure that what we do is not only applicable to streaming. So at least the very basic idea of streaming and real-time calls should be addressed from day one. And we discussed like our options. So the first thing in green is what we are trying to kick off today. So identify relevant activities in different standardization units, in different research communities, and in the industry, and organize a first way of cooperating between the different players to see how far we can go. And then ideally develop a framework to define, first of all, the key concepts and models. Later on, if that's possible, even a way to do the continuous monitoring or management of POE in the network. So yeah, this is more or less where we are. Summarizing the target of today is these 3 points. So first of all, this be on the same page target. So describe the current status from different perspectives, from different industries, from industry, from academia, from the standard. So basically having the global picture, all of us. Second, identifying which are the key areas that we should address as a research and industry community. So basically, which are the main gaps that are identified and that should be closed so that the QE management in general improves in the future. And finally, discuss how VQuick could help. So basically, which could be our role as VQuick in this whole story. We are a small part of this story, but we are a part in a very nice position of having, or being in the crossroads of the different, industry and research communities of different backgrounds. So maybe we can really be an important player in this whole story, and maybe we are able to create something which is useful for the whole wider community. So this is the target. It's a bit ambitious. Let's hope it goes well. And this is the agenda of what we are presenting today. So it's divided into clear slots with a break in the middle. We'll see how we are able to manage the time later on. So the first one after this introduction is about a broad state of the art. So we'll first have a presentation by Michele Sorzi, and then the second one that I will probably do in the name of myself and Tobias Hosfeld, who's also connected. So covering a couple of visions from the research perspective, and a third one by Chel and Gunilla about the current status of the standardization industry. I hope that we can get an overall view of the state of the art before the break. After the break, we'll be more practical, I hope. We'll have the vision from one content and application provider. In this case, it will be Meta with Francois' presentation, and the vision from a communication services provider. It will be AT&T with a presentation from Emure. And finally, we'll have an open discussion with a panel that has, I would say volunteer, no, you haven't volunteered, appointed to be part of this panel. Thank you for accepting. But hopefully with the idea that it's not just simply a panel discussion, it's mostly an open discussion with anyone here, and especially remote. So we have the panel to kind of trigger the conversation, but we really expect everyone, and especially remote ones, to participate, because we have a large representation of the research and industry community remote today. Thank you very much for coming. So, okay, that's all as an introduction from my side. And of course, I don't know if there's any comment or question. I speak very quickly, but yeah, that's a defect that I do have. Okay, so thanks a lot. So I will, I don't know if we can show, well, I guess that the slide will come eventually, but I'd like to introduce Michele Sorzi, who's online, who will give the first talk today. So he is a professor of telecommunication at the School of Engineering in the University of Padua, and he has a lot of honors and awards. So he's IEEE fellow. He has several Lord awards and research fellowships, several best paper and tutorial awards, and it's basically one of the well-known names in the communication research arena. So thank you very much, Michele, for accepting giving this talk today. And yeah, the floor is yours.
Okay, thank you, Pablo. I hope you can hear me well.
Yes, perfectly.
Share my screen here. Let's see here. Okay, now I should be with the presentation on the screen, right? Can you see it?
Yes, thank you.
Okay, all right then. So thanks, Pablo, for the introduction, although you gave many spoilers about what I'm going to talk about. And thanks for the invitation to deliver this talk. I should say that, despite the generous introduction that Pablo gave about myself, I don't consider myself an expert in this QoE kind of environment. Of course, I did a lot of work on networks and wireless systems, so I'm more on the QoS side. And in fact, this disconnect or difficulty to understand each other is one of the main messages of this talk, which hopefully will be one step towards a better collaboration, a better understanding between different communities. Now, this presentation has been put together with the great help of two colleagues. One you know very well, Federica Battisti, who's also online right now. The other is Marco Giordani, who's also my colleague from Padova, who collaborates with me on the work that I'm going to present. And so QoS and QoE, so we can start from definitions. You can pick your favorite definition or look for definitions off the web. And immediately when you read them, you see there is a significant difference or multiple significant differences. One is that quality of service describes the measurement of some performance of a service, be it in the case, for example, communication network, as experienced by the user. And so examples could be, the kind of data rate you can experience or the delay you incur when you try to send packets from one point to another. Okay, so the user will see this performance, although they relate mostly to, we could say, lower layer parts of the system, whereas quality experience to me relates more to the higher layers. So this is the quality experience by the user at the very application. And so the actual experience of using a certain service, which of course will depend somehow on what happens down below, but it's more direct and more directly related to the user's satisfaction than it is, for example, bit error rate. Okay. Now going further in the differences, so usually QoS is related to networks, so it's widely used by the networking community, whereas QoE is more widely used in the multimedia community. Excuse me for simplifying things a little bit. QoS typically is characterized objectively. So we know how to define it precisely, and we know how to measure it by simulation, experimentation, or even analysis. And so to some extent, it's easier to deal with QoS because it's better defined and easier to measure, whereas QoE is typically characterized subjectively, and as such is harder to characterize. So you can argue that there is more randomness because the user is part of the actual measurement process, which gives a lot of randomness to some extent, given that we are all different and we have different preferences and different tastes. So I already gave some example of QoS metrics. You've seen this before, I think many times, throughput, goodput, or delay, or capacity of a certain system, reliability, error rates, delivery rates, things like that. And these, we can measure by simulation, and we get numbers with their own statistical confidence, but this is, things we have been doing for a long time. Now, Paolo was mentioning some standards. Also, there are industry groups, and they proposed documents with use cases, and for each use case, they provide a list of metrics that would be desirable or required. So here's an example for a couple of application areas. One has to do with industrial IoT, the other with vehicular networks. And typically what we do, we describe the service, so what the service is meant to do. And then we say, well, this service to be effective or to be acceptable needs to meet these requirements in terms of maximum latency, for example, or minimum reliability or data rate that should be provided. And typically this specification is multidimensional. So you have multiple metrics that should be met together at the same time, which makes the optimization a bit difficult, or you can address this optimization in several different ways. For example, you could do a multi-objective optimization with maybe a linear combination of the metrics you want to optimize according to some coefficients, or you can have a constrained optimization. So you take one metric as the objective function and the others represents constraints that need to be met. or you can explore the feasibility region. So what are the configurations of your system that simultaneously meet all these requirements? So you come up with a multidimensional region, and the boundary would be some kind of a Pareto type of trade-off description. So there are all possibilities, to use these descriptions to design your system or configure your system in order for it to meet these demands. So as an example, and to show you how, in our community, this may lead to a solution which you'll probably recognize as a bit off with respect to your own culture, let me give you a piece of work we did recently with Marco. So it's about autonomous driving. And in this case, clearly I'm giving you a simplified view, but in this study, there are two metrics that are considered for QoS. One is latency, the other one is reliability, which basically means that we have a latency constraint, 50 milliseconds in this case, and packets which are not received or packets which are not received within the 50 millisecond limit are considered as lost. And so we want to guarantee that those packets which are in fact received within the latency constraint are at least some percentage with many nines, so 99 or 99 point whatever number of nines you want, which is what the network is asked to do, okay? And clearly, we can decide how many resources the network needs to achieve this objective, and this will depend on the amount of resources, the way we use the resources, so the protocol stack, all the the algorithm and the different protocols at different layers. It also depends on the traffic demand, which is imposed on the network. And clearly, if you see this in a future perspective, where we will have typically a large population of vehicles, so we're interested in maybe congested areas, and so many nodes, each producing a lot of data, because we're going towards high-end sensors like video cameras or lidars, which produce really a lot of data. There is this sentence down below, which is taken from one reference, which uses this weird data rate specification, terabytes per driving hour, but 1 terabyte per driving hour is essentially a bit more than 2 gigabits per second, which is clearly on the high side. And so dealing with this huge traffic imposes a tremendous effort to the network and to the network design. Of course, I don't need to tell you that one solution is to compress. You don't send the raw data, but you can send a version of it which contains most of the information you want. And there are, of course, multiple ways to do that with their own pros and cons, different trade-offs between distortions you introduce and the data rate you need. Now, clearly, if I'm a network designer, I want my network to deliver packets timely, then reducing the traffic helps me, right? So if my focus was only QoS, so putting the network in a situation where it can work effectively, my best bet would be to compress as much as I can, right? Because the lower the traffic, the better the network performance. But obviously, the network may work very well, but the data it carries may not be that useful. And in fact, if you want to maximize the quality of service, you will send close to nothing, because then the network will work perfectly. But then, of course, the utility of this network is not there. A similar paradox arises when you deal with energy efficiency, for example, where the most energy efficient way of operating a network is to shut down the nodes and let them sleep the whole time. But obviously, the network then does nothing useful. And so this is clearly not the way to go. And so in order to compensate for this or to properly capture this trade-off, we introduced what we call QoE, and the quotes are because, you realize why I use the quotes here. So to us, QoE was related to the meaning of the data we transmit. So if we send high quality data, meaning data which represents with high fidelity, for example, the information we want to convey, then we have a high QoE. Whereas if we degrade because we compress very heavily and so we give up a lot of information, then our QoE suffers. Okay, so it's more of a QoE not related to the experience of a human user, as seems to be the case, in the multimedia community, but it's more related to, the quality of the data we send versus what the network can do with it. Now, of course, the two things are not completely separated, because if I send packets over a network which works poorly, then the network will lose packets, and this will mean that my information content is compromised at the receiver, not because I chose to compress heavily, but because the network lost many packets. Okay, so they're not completely separated. So the network performance, especially when it's poor, may heavily affect the quality of experience as I define it. But by and large, if you do your design well and you have the proper amount of resources, then you can assume that the network does its job perfectly because we put it in the condition of doing it. And then at the same time, you control the quality of the content, right? And clearly, since the more content I want to send, the less quality of service the network is able to provide, we can identify the trade-off there. And so that's what we wanted to study. So how do we define QoE in this context? And as I said, QoE may be a misnomer in this context, but to show you where we come from and why, as Pablo was saying, if you pick results from different transactions from different communities, you get quite different results, right? So one thing that we may want to do in vehicular networks is to have pictures to show the environment, and these pictures will have to be sent somewhere. So in this case, PSNR is a performance metric we can use, or we can use subjective testing. And of course, in this case, the two are quite highly correlated, at least under some conditions. And so, what I see as bad, the picture to the right, will correspond to a low PSNR. And so there is this correspondence between what I can measure objectively with some mathematical metric and what I can see visually as a human user, which I can define good or bad. Now, things become a little trickier in other examples. For example, a LiDAR point cloud, which, of course, if I compress it, then visually I can see something has changed and some information has been lost, but then the effect of this information loss is harder to capture for a human operator, because then I use the point cloud to do other things. I'm not consuming it directly as a human, as in the case of the picture of an image, but here there is some algorithm which will take the compressed point cloud and do something with it. For example, try to recognize an object, and the performance of the object recognition algorithm, I cannot mimic as a human operator. I cannot predict how that will work based on the point cloud I see, the compressed point cloud I see. So there is here already a disconnect between what a human user could appreciate based on vision and the performance of what the system is supposed to do, which is detecting objects. Okay, and so here already we see that there is a trickier type of definition or use of this metric, which will have to be studied and understood more clearly. Okay, so what we did was to identify a number of compression mechanisms based on compression and quantization. We number them, and then we study how they perform in this case. And we can decide to compress more and help the network, but lose information and vice versa. And so that's basically the trade-off we're trying to study, which to us was the trade-off between QoS and QoE. Okay. Now you can do this in several different ways. You can use, again, one of the two as a constraint and the other as an objective function, or you can define a reward which is gained when you use a certain level of compression and you have some corresponding level of performance for the network, and then use that reward to drive a reinforcement learning algorithm, which tries to converge to the proper action according to the environmental conditions. And so this is what is basically studied in this paper here. So essentially, if you look only at the QoS, then you can compare different schemes and see, that some meet the delay requirement, some others don't. If you look only at the QoE, obviously, the more you compress, the worse you do. But these two, QoS or QoE only approaches don't really account for the whole picture because they miss completely one dimension. If you join the two into this reward mechanism, then you get the graph to the right here, where you see that these blue bars to the left, which are the reinforcement learning based approaches compared to the benchmarks, can do well, in essentially in all cases because they try to jointly optimize the two, and so they intelligently try to play the resources or use the resources so that both metrics are satisfied or are at least considered at the same time. Okay, so this is what we consider as QoE. Now, I'm sure many of you will think, well, this is not what we mean by QoE, right? Because QoE, the multimedia thing, the user experience, the user preferences, the satisfaction. So this is where the disconnect is. But I think you understand why we come from that side, because our culture is more towards numerically characterized performance metrics and how we can trade off them or optimize them jointly, right? Now, you come from a different community where this is what you're looking at. Maybe immersive media is, one of the big topics today in the multimedia community with virtual reality. And so, you may have different ways of realizing these type of applications with devices, head-mounted devices, and the different levels of immersivity, different levels of interaction with the environment and between different users. And so this is where another QoE definition comes from. People tried to do this, to give this immersivity in some ways, which maybe were not that successful. We all remember this experience, at least I do. I went to the movies back then. This is not actually new because things happened even well before then. At least that's what Federico tells me. I didn't know directly this kind of examples here, but basically what we observe when we look at these experiences here is that the attempt to provide this three-dimensional or this immersivity type of perception didn't really fly for many different reasons, and I'm sure you know them very well. So first of all, there is some inconvenience related to it because you need to use devices, you need to do something that is not natural, right? And so this is something that may be a barrier or just simply a discomfort. The attempt to reproduce this three-dimensional experience may have side effects from the physical or physiological perspective. For example, you have eyes may be strained, or you may have dizziness, nausea, or sickness because of this, moving in this virtual environment. So somehow our body has a hard time to adapt to this type of experiences unless they have some specific characteristics and performance levels which prevent these type of things, but we're not clearly yet there. Sometimes the technology to provide this experience compromise the visual quality in terms of brightness or color. And so maybe, you have this two-dimensional perception, but the quality of the color you see is degraded. And so all in all, what you get as an added benefit from these technologies doesn't really pay off. It's outweighed basically by the drawbacks, at least in the current status. And so the lessons we learn from this story here is that, well, first of all, problems are not only technical, right? They have to do with when it comes to our body, our perception, our satisfaction. There's more to it than just technology and technical solutions. In order to capture this, a quality experience in a fuller sense needs to be considered. A quality of service by itself, simple as it is to handle, doesn't give you enough of a tool to make these experiences actually fulfilling. Okay. Also because it's not very well established as a concept, it's more elusive than quality of service, and also because it's not as easy to measure, unlike quality of service. And so this, especially for these immersive experiences, becomes very tricky and very difficult. Now, of course, there are ways we can define quality of experience, and I know you guys have tried to do that. There is, efforts around the world with different interest groups and organizations that try to go in that direction. But it's interesting because supposedly we all can distinguish a high quality thing from a low quality thing, right? We may have different thresholds from what you consider acceptable or not acceptable, but by and large, if something is high quality and something low quality, you can tell the difference, right? And so this is something that when you see it, you can recognize it, but describing it and even more measuring it is tricky because there's a lot of subjective things, a lot of nonlinearities, for example, because maybe our ability to perceive high quality saturates. So high quality and higher quality may not be as easy to distinguish unless you have maybe a special training or special education in a certain field. And so this is the challenge that we have in there. So as I said, this is what Federica provided as the current definition of quality experience for an immersive media experience here. And, as I said, the groups have been studying this. Another challenge that these immersive services, they're not very mature. So maybe we don't have enough knowledge, enough understanding, enough experience with these to be able to characterize them as well as we can, for example, with 2D or video, the traditional video content there. Now, some research questions that could be posed here in this context, right, to face this difficulty. So let me group them in two groups. So the first set of questions is, what are the factors that impact the quality of experience of the users? Or what are the main differences between 2D and more traditional characterization and the new immersive media type of context? And what can be guidelines to do subject testing in a reproducible and systematic way? These are hard questions. One thing that we did was to study or to look at these kind of questions. Now, of course, we have, in terms of quality features, what we inherited from 2D and traditional video content, like video quality, audio quality, and synchronization between the two, as well as how they relate to how much data we have in terms of storage or in terms of communications. But then, of course, there's much more to it when you go into immersive experiences in terms of natural experience, in terms of how the system is, the data is captured, how it is displayed, how it interplays with our body, and how it gives us discomfort or comfort. And so these are clearly the set of features is much richer in this case. Now, what we did was try to identify the main issues here, and two of them are listed here. One is what is needed in terms of transmission. So how much traffic do we produce when we want to use such a system? And what kind of experience do we have in terms of signals, which seems to be one of the main issues here. Of course, there are other aspects, but these two were the focus of this study. And essentially what we did was to design an experiment, ask people to do something, and we measured jointly the data traffic, the movement of the users, and the level of sickness through a questionnaire, which is filled out after the experience. And so what we try to do is to collect data which jointly characterize these aspects. And the purpose is to try to highlight or to identify possible dependencies or at least correlations between these aspects so that maybe we can say something or get some understanding of how these aspects are correlated, and this will help in the design. So this is the setup we did, and of course this mostly worked by Sara and Federica and others in their group. So there was a room which was equipped with this thing, and we asked a few tens of people to just play some commercial games, and then we measured different things, and then we asked them to compile a questionnaire. Now 60 of them actually were able to complete the experiment, and so we have full answers to those. 10 of them, which is actually a significant percentage, could not complete the experiment because their level of sickness was too high, so they gave up in the middle. So that also tells us something a little bit. And so we got results of this kind. So the left graph is the amount of data which was produced according to the user. And the right-hand side graph is a histogram of the answer to the questionnaire. So different symptoms. They were asked whether they didn't have it or they had it mildly or strongly. And this also reveals something, that some symptoms are more common than others. And so we can say something about this interaction between the user and the experience they are having there. And so this is basically a starting point to go into this immersive media characterization for the user's behavior and user experience. Virtual reality was the natural choice because it's ready from the technology point of view, so it was easy to acquire equipment and to design the experiment. But clearly, there are many aspects here that need to be highlighted and need to be understood because they relate directly to how we can design application, how the quality of experience will affect the user, and how we can maybe design objective metrics. Now, another question, can we define quality models? Because, what makes me a little bit uncomfortable in all this is that you need to get a bunch of people and ask them to do things and then ask them how they feel or what's their experience, which is, a bit different from running a simulation where a network transmits 1 million packets and I make statistics out of it, right? So one idea, and I'm sure I'm not the first one to tell you this, is to try to come up with a black box model. So we assume that there is an underlying function that maps a multidimensional input to some quality of experience measuring, whatever that is. And input can be a lot of things, right? It can be the network performance of the underlying infrastructure, the user's preferences, the level of traffic, the level of compression, anything which is more or less random. Some of these we can control by design. Some of these we can observe but not control. Some others we can't even observe. We don't even know what they are. There are some random effects which we don't even know about. And so this whole thing, which is a very complex model, is essentially a function, right? And so the question is, can we capture the essence of this function? Can we capture this relationship? Now, of course, this may be too hard to do by traditional modeling techniques. But of course, when you have something which is very high dimensional and with a lot of randomness, then data-driven approaches may actually be a better choice. And so maybe using some neural networks as universal approximators of unknown functions of high dimensions may be a way to try to capture these models, which then could be used to relate what the network does and what the environment does to a quality of appearance metric without having to go through the actually physical experiment of having people subjected to the actual experiment, which is time-consuming and hard. Now, of course, one can argue, well, this is heavily random because there's so many unknowns and so many even characteristics of the different people, which introduce a lot of randomness. So can we trust the result of this study? Well, I would argue against that how can we trust the result of a simulation study when we simulate a wireless system where the channel is widely varying in a very random way from user to user? So there is a lot of randomness, even in simulations we accept today as the ultimate way of producing simulation of performance results for communication systems. And so we shouldn't be that surprised that there is a lot of randomness because we accept that in other areas, but maybe we're more used to it. And here it seems more strange, but really we're talking about the same thing. And then if you want to try to reduce that randomness, we can, in fact, try to learn the user's preferences, right? And this also, I don't think is new. But, if I understand, if the user I'm dealing with is not just any random user from a huge population with very high variance, but I can characterize even roughly what kind of user I have, then I may do a lot of things to adapt my system to that specific user. And on the one hand, if I'm a user who often uses certain application, then the system can learn my way of using it, and in a future instance, it can provide me with the quality experience I want to have, which may be different from somebody else's. And we can do this by direct feedback mechanisms. So we can have scores, reactions. If I want my system to work well for me, then maybe I'm motivated to tell the system what I want. Or if I'm lazy, maybe there is indirect feedback mechanisms. So the system may be able to sense my frustration when I'm not satisfied, or my distraction when I'm not interested, or my lack of interest, or my reactions which are there. They're not explicit because I'm not telling anyone, but anyone looking at me will know what I'm, what kind of experience I'm having. And so maybe combining this, we could train the system, customize the experience to the single user. Well, then you say, how about a new user whom you don't know? Well, can we at least roughly classify a user? When you meet someone, we immediately see something and we immediately get an idea of who we have in front of us. So can the system do the same? Can it, from the first movements, from the first, the initial interaction, can it roughly classify a user? And then maybe refine this classification as we go, maybe providing inputs that may trigger some reactions. So this may be futuristic in terms of, availability of this technology, but these may actually go somewhere in this for this objective of reducing the randomness, or trying to control a little bit more what the system does, instead of trying to propose to a user the experience of the average user in the world, which may not be adequate for them, right? So to conclude, let me give you two slides, one with summary and one which is a little bit more like a position type of thing. So the summary is that we're not quite there, at least as I understand, to define quality of experience for immersive media. There are many parameters that affect this experience, and they're not all easily controllable. And so it's a complex problem and highly multidimensional. In addition, we don't have a good model, I think, for the behavior of our human visual experience, not yet, at least, and partly because this is a new field, and so we need to collect data and experience in order to be able to understand better what happens. And what makes this more difficult is that, well, first of all, compared to traditional video or 2D characterization, this is, significantly more difficult to capture. Unlike traditional media, where the experience is essentially unidirectional, then you here can have interaction with the media and also between different users, and so that makes the experience much more complex. And also multimodal interaction, so audio and video, but maybe tactile interaction in the near future may add even more dimensions and make the characterization even harder. So clearly, networking and multimedia are more and more intertwined than they were years ago, and I would say that they will become more so in the future. And so this interaction between the two communities and two technologies cannot be avoided, right? Synergistic approaches need to be developed, joint optimizations need to be pursued. And currently they're not there because we have different cultures, different languages, different objectives, and we don't really talk much with each other. And so sometimes these may be even conflicting objectives, as I tried to explain with the autonomous driving type of application. So for a successful approach, I think we should first unify or at least make it decodable or translatable our languages, so that when we say QoE, we mean the same thing. Not as, I argued earlier that, I talked to you about QoE, and while I thought we have two different things in mind, at least we need to understand each other. Plus, we need to understand each other's objectives. We don't have to have the same objective, but at least you need to know what I'm doing, and I need to know what you're doing, and to see how we can work together, and also understand how technology can support a fulfilling user experience, and how such an experience can be provided based on the available performance. This relates a little bit to one slide that Pablo had earlier. One was the content provider with some mysterious network, and the network infrastructure with some mysterious application. I'm the network, you are the application. You can tell me what you want, and I try as hard as I can to provide it to you. Or I can tell you what I can do, and you decide what you can do with it, given the flexibility you have as an application. Okay. Or maybe we can try to meet in some middle ground where we are both flexible, and we can jointly optimize the union of the two systems that will then optimize the usage of resources towards providing a fulfilling experience to the user. So the next steps we could have in this certainly joint discussions and collaborative research. I'm happy to say that here in Padova with Federica and Sara and others, we have taken a small step in that direction. And so we bring our experience and our testimony to this community, that maybe some steps can be made. We should design experiments that are able to capture the trade-offs in a global sense, so capturing both the communication network infrastructure and the application and user perspective. And this is also something that Pablo mentioned earlier, new data sets that are collected with these objectives in mind. They're published, they're made available to everyone, so that we can create a common culture and common set of tools and of data which can be used to test, to compare solutions, and to invent new things towards this objective. So with that, I hope I didn't go too long, and I'll stop here. I'll be happy to take any questions, and I'll be even happier to defer questions to Federica, who's still there, because she's the one who's more into these topics. Thanks a lot.
Oh, thanks a lot, Michele. So any questions from the audience, local or remote? Yeah, Christian.
Yes, thank you very much for the very nice and interesting talk. Actually, I have more like two comments. So one is on the QoE definition you came up and that you took from Wikipedia. I think they are citing the Qualinet white papers. So you might look into that. It gives you also a framework, not only the definitions, but also a frameworks of the influence factor that you also briefly mentioned. And also later on, we also produced, I think, one for immersive media, which is related to the last use case that you have presented. And actually, some of the co-authors are sitting here in the room of these two white papers.
No, Federica, so the first slide was from Wikipedia, and it picks from there. But then, later in the presentation, there was an explicit reference to Qualinet and to the white paper that Federica provided with the new definition. Definitely, recognize that this community and groups around this community are providing input in this discussion, right? And
I see a clear gap here in the different communities. Also, Pablo mentioned this already in his introduction, and you also came up with the same conclusion that there needs to be a stronger collaboration between these entities. In terms of video coding, I also, maybe I'm not sure you heard about that, but in MPEG, maybe also in JPEG, there are now new initiatives starting. They are called like video coding for machines, which is like related to the first use case on autonomous driving. where like the recipient is no longer a human receiving video data, but it's like another machine receiving the information and then making decisions based on that. So that might be also something which could help here. But I'm not expert in that, so I don't know how far they are. But I know that's happening, and also for audio, they starting with same or similar approaches that could also help here in terms of the requirements that you have, like you say, for latency, the quality, and so on.
Okay, thank you. Thanks.
Thank you, Michele. My name is Narciso Garcia from Madrid, in Spain. I enjoyed very much your talk and also the Paulus one. There was no question before to appreciate that. And I take in your last message saying unify the language, share and understand each other objectives and understand technology. And my question that is in some sense provocative, that means is not a plain one, is I think that both communities, QoS and QoE, live very well isolated one from the other. So there is a need to push them just to merge them, because there are conferences where you can discuss QoEs with your colleague or QoEs, conferences where you can discuss QoE with your colleagues there, but there is not a common playground just to merge the two people. I would like if you have any idea on this topic.
Yeah, so I agree that if you look at two aspects in isolation, maybe assuming that the other is the way you want it to be or perfect or whatever, then it's a bit limiting. Clearly, it's challenging because you need to bring together communities. But what I said in the very last part of the presentation. So the next steps could be joint discussions, joint projects, collaborative research. Experiments which are defined together, by Federica and I, where she brings in the multimedia needs and experience and view, and I make sure that from the networking perspective, nothing is taken for granted or too simplified. As hard as it can be, this is an effort which could give us a good way forward in this. So unless we get our hands dirty and we, sit together and try to do something which is hard, I don't think we're going to go anywhere. We'll still live happily, in our own isolated communities, which is fine. I mean, we've been doing that for many years, but we're not making progress in this effort here, which it seems, in this context is what we really want to do.
Thanks. Yeah, Tobias, go on.
Hi. So from a networking perspective, what is your opinion? Would it be sufficient if we know, let's say, the thresholds for, how fast the packets are delivered? So let's say latency bounds, and we know those thresholds. Would this be sufficient just to engineer the technical system? So this means the 6G networks? Or do you think that we are missing something?
Well, as a network designer, so from the point of view of the network designer, if you give me a number of constraints or requirements, I'll do my best to meet them, right? Now, if you ask me, well, is guaranteeing a certain delay sufficient? Well, I would say no, but you should tell me that, guaranteeing a delay maybe it's not enough because you have to guarantee some jitter. And also, if you're losing packets, then that should also be a threshold. So it's inherently multidimensional, right? And so, and even when you see these specifications, from the 3GPP, where they give you a bunch of numbers for the different thresholds, but is that real? I mean, it maybe asking us to meet all these thresholds at the same time, maybe it's too much because a lot depends on the application. And so maybe we're over-designing the network even. And so there also more discussions should take place because there may be, these networks are meant to support multiple applications together, and all these applications will have different requirements. And so how we can, put them all together, guaranteeing that each enjoys the quality it needs and possibly no more, and everybody's happy, is clearly a tremendous optimization problem to solve. But that's where the holy grail, of network design is these days, because it's a heavily heterogeneous, and there is a lot of flexibility, but also of the diversification. And so being able to control everything together is clearly a big challenge. But yeah, that's where we're going. Unless we slice everything and we separate everything, which will be inefficient from a different point of view. Clearly, I mean, we have to take this challenge, right? Otherwise, we won't get there.
But that's the point, if slicing solves the issue or not. But in principle, yes, we know
Yeah,
it's costly.
sure. Yeah.
Thanks.
Yeah, I have a question.
Thank you.
Thank you. Yeah, I have one question here. Thank you for your presentation. My question is about the QE and let's say all components on the video streaming pipeline should know about the QE, because from a network perspective, we don't let, for example, ISPs to know about the QE. They have to extract the QE from the encrypted data. Do you think that we should find a way to let ISPs know about the QE or not? We need to know, for example, have some collected data from the QE, from the client side and from the origin side or content provider, and then only knowing these two entities about the QE is enough. What do you think?
I don't know. I don't know if you have to expose the full QoE directly to the network provider, but actually, certainly you have to let the provider know what you want, right? What makes you happy, because otherwise you're not going to get it. Or either you over design the network so everybody's happy by design because they get more than they need. But if you want to tailor the resources very carefully, then you need to provide as much information as possible to the network operator so that you can get what you really want. Now, Pablo was showing earlier some signaling diagrams where there was some QoE report or something from the user to the core network, which is probably what is needed here. So some way to let the network know what you need, whether you're happy with what you're getting, or you need more, or you can be happy with less. So some adaptability, some adaptation, which of course is based on the network's flexibility to modulate the performance on a very fine granularity, but also you need an indication from the users of what they need or whether or not they are getting what they need, because this is probably it closes the loop for the control of the quality here.
Okay, thank you.
Okay, thanks.
Thank you.
Okay.
I take the last question, benefits of being the host, which is maybe something a bit specific, but you mentioned that, we use QoE in a way to model these QoE QoS trade-offs. We have functions that we use for this optimization, like PSNR and stuff. We know in this community that these are very limited ways of modeling the user experience, let's say. So if we could create a better way of modeling the user experience in a function, which kind of function you would like to have? So basically, which is the kind of metric that we need to build as a multimedia community that is useful for the networking community?
Yeah, actually, I think answering this question is research itself, right? Because I don't think I give you a straight answer. Oh, this is what I need, because to understand what I can use and what you can provide and where the meeting point could be, I think would take some good discussion, which to me is really research in this context. So I hope this discussion will take place, and maybe a year from now we will know the answer to the question.
Great. Thank you very much.
Thank you. All right. Bye.
So we go to the next presentation. This is something well, jointly done by Tobias Hosfeld and myself, with most of the slides done by Tobias, of course. But kind of in compensation, I will be the one doing the presentation. Yeah, so yeah, as somebody described in Pomex, I will be karaokeing Tobias' presentation. Let's hope it doesn't go too badly. Some of the slides are not this. Okay? So let's go. Well, I'll go quickly over the introduction. So basically, the whole thing is that we are putting new requirements in the network. We would like the network to be human-centric, which kind of means having better knowledge of what the users actually want and need from different perspectives, okay? So this is like the overall view, but I will not be so generic. I will be much more specific. I will try to cover a bit, starting from where Michele left the presentation, going a bit into our field with some fundamentals of the QoE metrics and modeling, okay? Mostly based on some Tobias work and others that I will mention. So first, let's start from the most simplest part, which is our beloved mean opinion score, which means that, of course, if you have one foot on ice and the other on fire, on average, it's fine, but still something is not working. So in a sense, when we use MOS as our golden standard of the metric that we are trying to model in this context, we are in a similar situation. If we have a number of people with a diversity of ratings, on average, it might be fine, but still some suffer. So if we assume that having a subjective experiment could be a reasonable model of our QoE, which is a lot to assume, but let's assume it's, let's take this assumption for this presentation. The whole information that we have is in the distribution of the user ratings, which is actually a random variable and contains the complete information on what's happening there. And there's a lot of work being done in VQuack on how to model this, and I will talk about this in a summarized way, let's say, during the presentation. So there could be other QoE metrics that cover different things from the compared to MOS, and one is the ratio of users rating good or better, which of course, given a test experiment, could be similar or could be a function of MOS or could be related to MOS, but you would require a specific fitting to understand that these guides who map rate the different things are put into a scale and see, okay, you have basically a ratio of how many of them are satisfied, how many of them actually have rated 4 or 5 in the situation. And still the MOS is somehow hiding dissatisfied users. So if you have a MOS at 3.5, it means that still only 50% of your users, if this is your distribution, are not satisfied. So in a way, you should somehow know how these quantities relate. So basically not only the mean opinion score, but also a bit more about the distribution. And this is these metrics were actually taken into account at the beginning of the let's say QoE modeling era, when QoE was not even a word that was used at all. But not only the idea of the mean opinion score, but also some information about the distributions of the scores. So we would have the SOS, the standard deviation of the opinion scores, or the percentage of users rating good or better, or poor or worse, or any other quantile that we want to have. Something that Tobias has worked on a lot in the last few years is this SOS parameter. So trying to capture the simplest possible way of actually relating all these quantities in a way that makes sense. And this is this probably known to most of you, SOS hypothesis, which is basically that for a given subjective experiment, so the one that we do regarding QoE, there's a very there's a kind of a simple relationship between the mean opinion score and the standard deviation of the opinion scores. So somehow they tend to follow this kind of pattern that you see in the picture, which is different from other kind of ratings. So as we discussed it before in Loic's presentation, if you have like people rating movies, you will not get, I mean, like I like this movie, I didn't like this movie, you will probably not get so easily this kind of distribution. The nice part of this kind of distribution is that you can make the simplification of mapping it to basically a quadratic function, and you have a scale-independent parameter which will describe this relationship. And this single parameter is very curious because it depends a lot on the type of content that you rate, and it somehow models the variability of your users, and it's very characteristic, meaning that video experiments have a different rates than speech or web browsing experiments. So it's a way to put things more or less in the same scale somehow. Another approach to user rate modeling is the one that we have been discussing in the SAM group for a lot of time and a lot of meetings. There have been several models proposed. I will pick this one because it's simple but kind of informative, where we model the user scores as a random variable, Q, which will depend on the content and on the user. And basically, we assume that the scores come from a distribution. So the scores for each user come from a distribution which deviates from the true quality, like the most that we are targeting, let's say. It's not the most, actually. It's, let's say, the true quality that we are targeting by normal distribution with some mean, which is the user bias, and some variance, which is the user variability. So that basically, for a given stimulus, the user will have this red probability of scoring 1, this orange probability of scoring 2, and this yellow probability of scoring 3, and so on and so forth. So the thing is that this has been quite well analyzed, and there was a nice study that I contributed a bit, but it was mostly done by Jakub and Lucian and other collaborators from ADH, which showed that this particular user modeling has very nice properties. It's better even than having the empirical distribution of an experiment to model the global opinion of the population. And it is also nice because it leads to the same conclusions as the SOS hypothesis. So if we consider not only the scoring of a single user, but the scoring of all the users on an experiment, we will see that basically the bias will be cancelled, and we will have the normal distribution of a normal histogram, let's say, where these red are the ones that we get, these orange are the twos that we get in our experiment for a given condition, where its true quality is moved. And the good thing is that with this model, the variance is constant for all conditions. I mean, this is of course not true, but what we know is that with this paper is that this is a good approximation. It's basically quite equivalent to the SOS hypothesis. This is something that I worked on a bit last year, and you can actually map empirically two values. So basically, you can reinterpret all the SOS parameters that are in all the papers out there as the standard deviation of this underlying distribution. So this is an interesting tool that I will be using a bit further in the presentation. I will talk a bit more now about how this QoS to QoE metrics can look like. And again, well, this is a bit of the description of different layers that we have. So basically, we have this QoS metrics and KPIs monitoring the network and the user side. We can monitor what's happening in the application, and we would like to understand what's happening in the user. So basically, we would like to have mapping functions in both levels. So we need to understand which kind of studying events we're going to have if we have some problems in the network, for instance. And of course, we need to understand the mapping between the objective quality that we have here and what the user understands. And all this is influenced by several context factors that we discussed a bit. And the key idea here is basically understanding which are the main context factors that we should actually introduce into our models. Because if we try to get this whole system context and user influencing factor model into an actionable model, it's not going to converge to anything. So somehow we need to figure out which are the right factors that we can introduce into a model so that this is kind of correct. Of course, we are not inventing this. This started to be worked on in the 70s with the only use case that we have at that time, which was analog telephony. And a lot of QoS to QE models have been developed in the last years. If we think about the ones starting that actually measure the network, we can say that we have opinion models, the one used for plannings, and monitoring models, the kind of B-stream or hybrid rate monitoring models where you measure the network and actually provide a metric of what's happening in the network. Yeah, there are lots of ITU recommendations working on this kind of models that we haven't discussed here. This is only a subsample of the thing, so I'm probably missing a lot of stuff. Don't take it for granted. There's even one ITU recommendation, which is the list of the relevant recommendations, T1011. So go for that. You can read it and use it as an index for everything else. But I will use one of the most recent ones, which is the 1204.3, as an example of how these things could look like. And I will not take credit at all of these slides. These come from Rakesh's paper, and of course from the work that a lot of you have been contributed to. Okay, but the nice thing of this model is that it covers a lot of the elements that I was talked in the presentation before. So it's basically a combination of a parametric model and a trained model. The parametric part basically tries to map in a very simple way the video quality based on three different elements. So first of all, basically the quantification parameter. So this quant is basically the QP of the encoder with some scale correction, mapped exponentially to the mean opinion score. And then we will add some degradations if we are looking the video at a different display rate as the decoding rate. So basically, if we are upscaling the video, it will be impaired. Or if we are reducing the frame rate, so it will be impaired as well. The standard uses this linear combination of the impairments because, for something well known, let's say from the modeling research, which is this transmission rating scale, for which there are some mappings between MOS and this R scale. So the nice part, maybe it's a bit too quick, but the nice part is that this R scale is actually linear to the so to the mean scale of the underlying Gaussian model that I presented a couple of slides ago. So it's specifically, this is the equation that maps the R scale to MOS according to the standard. This, given using a very old paper from the 70s, is how you can actually map this R value to the underlying mean, to the underlying mu, let's say, scale, which means that using this R scale, you should be able to directly estimate this good or better, because this is basically on the green part of the Gaussian, or the poor or worse, which is the red part of the Gaussian. So you could have access to this more complex metrics rather than only MOS, assuming that you do probably another round of mapping, because this mapping was actually derived for speeds. So maybe to be able to do that, we should derive a new equation for video, which is not part on the video standards, at least so far, but maybe we can take it for the future. Okay. And I said before that the interesting part or one interesting property of this model is that it has a second half which is trained based on a number of features that have to do with frame rate, resolution, bit rates, and some statistics of the coding parameters and the network parameters. And then the whole prediction is basically a weight mean, and I think that the weight is actually 0.5. So basically an arithmetic means of both contribution, the parametric one, which is simple and very explainable, and the trained and the trade part of the residuals. And the nice part is that it works. I mean, that the results in the paper and out there are other papers validating the network. I mean, the metric later on is that, you know, you will get different results depending on the data that you use, but basically it's BMAP-like performance. So it's really state of the art. It's something that's really, you can really use. So we are now in the position that we have metrics that where we can use to map or to close a bit this gap between QoE and QoS. So maybe this is a nice starting point to contribute to this discussion. The third part of my presentation is a bit going more into these fundamental relationships of QoE compared to QoE. It's a bit more theoretical, but still relevant because it has some interesting implications. So basically, the whole thing is that we can consider the quality as a random variable, as I said before. And what we measure is basically the quality given some conditions. And we can have a function like the MOS model where we can model basically how could be, ideally, we can get the MOS given some conditions. So this is what we get if we apply this P1204.3 model that we brought before, okay? And on the other hand, we have that these conditions that we are applying here are also random, as Michele said. So there's a lot of randomness and variability on the network conditions. And an interesting question is what would be the expected value of Q of the quality across overall system? So the system QoE, we can define it as the expected value of the quality, which is basically the expected value of the MOS or modeling function across all the networking conditions. And a nice important thing is that since this function is not linear, we cannot reverse the application of the function. So basically, the expected quality in our system is not the applying MOS to the expected value to our mean QoS condition, let's say. Then we have this equation that I will try to, go a bit quickly, but basically what we get here is that, the derivation of this idea, which is that the system-centric QoE is, we can apply the law of total probability. So basically we have the QoE across all the possible conditions, and then this is the QoE derived from our study. So this is what we can map in the mean opinion score function. So this is this expected value of Q given T. This is our MOS mapping function, that this is the one that we have to integrate across all our networking conditions. Another derivation of this, or another aspect of this, is that this QoE distribution, which is what the distribution that we have of user rating different QoS conditions, is basically a discrete distribution, because we are asking users to actually to rate in a 0 to 4 or 1 to 5 scale, while the MOS distribution given a QoS value or a networking value is going to be continuous. So basically, we are having here kind of a mismatch between both things, let's say. So basically, somehow when we are doing this, like taking the mean, we are hiding the fact that we are starting by a discrete distribution in the opinion scores, and we are trying to map some values to a continuous function, which will require a bit of data manipulation that can lead us to different conclusions, let's say. But still, with this kind of analysis, we can get like other kind of fundamental relationships to know, for instance, which is the probability. So which would be the fraction of users that would be rating good or better given some conditions, or given all the conditions of our systems. And again, this is something that we can only apply if we have a good or better mapping function to the network condition, and then we apply the expected value outside. So somehow the message here is that beyond most mapping functions, we need to have like good or better mapping functions if we want to really predict the good or better condition, opinion or distribution of scores in our net. So since we probably don't have them yet, we need some approximations. And then which basically require a couple of things. First of all, having, as I mentioned before, this scales that can give you an idea. So probably using the SOS parameter or the sigma distribution of how wide the distribution of the scores is, so that we can model it. And for this to happen, we need to basically gather this information from the subjective studies, where the message is, it is not enough to report the mean opinion score in the subjective test. We need to have access to the rating distribution if we want to build this kind of functions. The good news is that if we use approximations similar to the one that I talked in the transmission rating scale model, or a beta function, which is a similar approach, you can still do reasonably good predictions of this good or better score. So it's not the nice part of doing our kind of experiments is that the statistics are very stable, so we can relatively easily characterize what is happening and have access to good approximations of the global distribution. So to conclude the presentation, the three key ideas is that, the mean is not enough to understand the QoE system. So we need some approach to the distribution of the scores, and maybe the normal models that we are discussing here in SAM and similar are also used to be able to access information. That we need these QS to QoE models, and the P12403 is a good example of how these things can be done. But of course, it covers a specific use case, so we might need to extend this model or the way that this model has been built to be able to apply it to other use cases. And finally, a bit more from the theoretical part, that we really need this kind of QoE distributions or approximations to that if we want to compute the global QoE of the system for any of the QoE metrics that I kind of defined at the beginning. So not only the mean, but the good or better or any of them. And of course, and this is my last slide, this is just covering a small part of the problem, because still we are assuming a very limited view of the QoE. In practice, we all know that the QoE is much more complex. So basically, we need probably better methods to understand what users think about. We also need to consider not only the quality of the users who are actually watching the system, but the ones who decided to drop because they have quality problems. And still, we need a better way to predict not only the scores of the users on an ACR scale, but actually what is going to be the user short and mid-term behavior, which is something much more complex. That has also been discussed here briefly, but still is probably the goal that we should have as a second. So that's all. Thank you very much. And I am open to questions, and I'm also be open to forward them to Tobias if he is the one to answer.
Apply the good metamorphosis to Tobias.
Yeah, it's all his work. Okay. So is there any question from the audience here or remotely?
I think just a comment. I mean, what you described in the end, maybe it seems more like the user satisfaction in general of a system rather than just the QoE as we used to think about it. I'm not sure if this can be really achieved with just parameters of what you can extract from the system, or because if you would like to take into account also users, the drops and so on, so it's more like an end-to-end behavior, not just of the system, not just of the transmission or communication system, but the whole, as a service, I would say, not just the application.
Yeah, sure. I totally agree. In fact, there is also this question of how relevant is the QoE as we measure it in the global perspective of the user, which is probably a question that we should answer ourselves. So how relevant is what we are doing in the global landscape of what the users are actually making value of, and how much we can understand this relevance and kind of connect. So how connected is our MOS or global queue distribution with the actual user experience, which is also a complex research topic. But I get that this is a question that we should somehow address. Otherwise, we don't really know if what we are doing makes any sense.
Thank you very much. Very interesting. But I had a question regarding this scaling. So because you had a mathematical model for the most values, so imagine that we could increase this scale from 5 to 10 or something. So we will have less error when we are mapping, right? So do you think it will have impact on the accuracy of the model? Because now we have only 5 scales that we map all the QoEs to this 5.
Well, the thing is that there's a randomness. So I don't know, maybe Tobias has a different view. Mine is that there's randomness on the task that we impose to the user. If you have basically a user scoring from 1 to 5, that you don't gain much more information if you give an individual user more options. Maybe something that I don't know. I mean, there has been actually some discussion about that in Vico time ago. I was not part of Vico at that time, but there has been some studies comparing 5-level scale to 9-level scales and so on. And I believe that the conclusion is that there's not much difference in what you get from the experiment. I'm not sure, you might remember it better.
Remember it similar to you, that you don't gain much. It could be nice for the test person to be able to have more levels to choose from, and also be able to score between. But then there was a paper, so I don't know that was the same kind of 7 levels is probably what we can handle. So going beyond that would probably not be gaining much, but maybe going from 5 to 7 would maybe gain a little. But in principle, I don't think it would make a huge difference.
Yeah, Alex, you have a comment or question?
Yes, thank you. I mean, there's quite a bit of work which is really already a bit older on this question. It's a very interesting question, I think. What would really make a difference would be if you provide a slight extension in terms of the categories beyond the 1 and 5, right? Because you see some saturation, which it was shown with this link to the R scale from the E model, right? And that you refer to also in your talk, Pablo. You see that, you sort of get rid of the saturation with this conversion to this R scale, right? And there are scales which can a little bit better handle this directly, right, in the ratings. And of course, it also depends very much on how people apply the MOS scale, right? Unfortunately, sometimes it is applied in such a way that you have a sort of slider, and then you have the worst and the best category put to the endpoints, right? And then obviously the categories are not equally wide, right? And then things which also further add is, do you use attributes? Do you use numbers, right? And then there's this debate about the semantic value of the attributes as well, right? Which differs across the different languages. So I think it would be actually a good idea to just dig out those different documents which have been also collected within VQuake over the decades, let's say, and maybe provide even some information about this scaling aspect.
Tobias, please.
Yeah, I think from a mathematical point of view, it would be nice to have continuous scales, of course, because obviously it has an impact on the variances and the standard deviations. So I'm not sure if it really plays a big role in practice if we have, let's say, 7 or 9 items on the scale. So really from the mathematical point of view, but in terms of load, when we are doing the tests via crowdsourcing, for example, it would be definitely too much. They would be happy if we only have 2 or 3 items on the scale to give a rating. But of course, then the granularity is not big enough. So then we have, so this is the mathematical point of view. It will have an impact on the SOS parameter and the standard deviations of the normal distribution.
Thank you. We have room for one more question, if there is. There seems no. It was clear. Thank you very much. Thanks, Tobias, of course, for preparing the material. I hope I didn't break it too much in my presentation. And so we are late because we started late. We keep the last presentation and then we go for the break later on.
It's how you want to do it.
I think so. So we started 45 minutes late and we are on a 45-minute shift, so that's okay.
Yeah.
Then the last presentation from this, I mean, before the break is, I guess, going to be given by Shell about the current status of the standardization and industry.
Okay, thank you, Pablo. I will try to give this presentation. It's about the current status and standardization in the industry, which I realized I was not so familiar with, but I try to do that. We've done it together with Gunilla and with a lot of help from several people like David, Pablo, and Francois. Thank you so much for providing input for this. This was a picture. Why is it so many stuff? Okay. So the picture to the right here is a way to maybe differentiate a little bit the different, let's say, responsibilities or organization taking let's say standardization for the different levels of the network. So you have the low level that basically covered by 3GPP, and then you have the transport and network layer taken care of by IETF, and the application layer with the WCAG and MPEG, partly ITU. ITU is probably more also spread out over the whole area. So I will just go through some of these. So the 3GPP, which is the Third Generation Partnership Project. So it's a joint effort of 7 telecommunications standards development organizations, and it seems to have 3 technical specification groups: the radio access network, the service and system aspects, and core networks and terminals. There are a few standards that could be of interest for us. I will not go into them deep. I mean, you can request them and read interpret, but there are service requirements for 5G systems, the QE parameters and metric relevant to virtual reality user experience, study on improved streaming quality of experience, reporting in 3D PP services and network, and network exposure API and C up to R18. They're also doing, having, of course, work item, work groups, and so on to progress. Examples of those is relevant here is the 5G real-time transport protocol, which will be also moving into the real-time XR media transport protocol enhancement. And also they're working on the 5G advanced codec support for messaging services. They also engage in studies about the enhancement for emerging real-time communication for WebRTC and study on beyond 2D video. But there is a lot more going on here. For the Internet Engineering Task Force, I just pick out one thing I thought was probably relevant here. Also here, probably quite a lot, much more going on. This IETF Scone Pro. So if the companion signaling protocol supports host to network metadata, then individual packets within the flow can contain metadata describing their drop preference or their reliability. So this seems to be kind of a way to handle how it should react if something is not going according to the wishes, and maybe have a grateful degradation of different behaviors. MPEG, of course, working a lot of video coding of different aspects. One big efforts there is of the MPEG-I, the coded representation of immersive media. There are several efforts there. They are not what I can see that directly related to the networking as such, but more on the application. So they are also working on the augmented reality application format. And also they have a group working on visual quality assessment, which is an advisory group devoted to support needs for quality assessment. I think we have also been collaborating with them a long time ago. It was for 3D TV. So, but then probably working a little bit parallel to what we are doing. And then there are the per picture quality metric reporting. This it was by David about this PCED, so the new standard suggested now. So multiple options for both metric and reporting frequency is supported for this per picture quality metric reporting. Going on to the ITU, I concentrated on study group 12. Probably Alex would have been much better to present this than me, or maybe Camilla or many others. But the target here is for the group as a whole, which fits this forum very well. It's like performance, quality of service, and quality of experience. And it's organized in 3 working parties and a series of questions addressed in the field of QE. And you have the testing methodology in VP1, Q7, Q10, subjective test method for VR, XR, and crowdsourcing. Working party 2, the QE objective models, Q14, the audio video quality of experience modeling, streaming, cloud gaming, quality of experience versus user retention. The test Q17, the test bed framework, Q19, no reference QE model collaboration with us, the VP. The VP working party 3, multimedia, QS, and QE. The operational aspect requirement for new services and the QE influencing factors, QE requirement for 5G services. So perhaps this computer team would be the one that is most or closest connected to 5G KPI. And then we have the WCAG, where I think this is very relevant for the 5G KPI with the embedding of metadata into the video stream. So there have been a method developed to include the metadata. So if the metadata could include the coding parameters and computed metrics for video quality, and that would of course be very useful for the networks and the networking protocols to be able to know the coding quality of the video, for instance. And then I also found this as an interesting. I'm not sure. I think it comes from your material. I'm not sure where it belongs, but it's the quality on demand API. It provides a programmable interface for developers and others to request stable latency and throughput managed by telco network without the necessity to have an in-depth knowledge of 4G and 5G system. And is it just an open source or is it belonging to a standard organization? I remember.
I'm not totally sure. I don't know if, but I can try to figure out. Soonish,
yeah. So to sum up, I give her a brief overview of the standards and networks for the standardization that could be relevant for 5G KPI. Most likely incomplete, but we could probably add to it while we work on this topic. And I divided it up in the application layers where WCAG and MPEG and IQ is responsible. We have to transport the network layer where the IETF is making a lot of standards, and then the lower layer for 3G. Questions and comments of this?
There is another group, IEEE, that I'm not sure if you covered or not, that
I didn't know. Yeah, of course, it was not in the material, but yeah.
I think it was in the package I sent you.
I'm sure.
Of course. That's the only one I didn't see.
Yeah, a good comment. Yeah, thank you. So we should add. I will go back and try to add it to the presentation of it, make it more complete.
Yeah, so I have the same comment, but what I noticed that we focus on standardization while we're using the users layers. What is interesting about the is that different layers are that. So there are some standards which actually do need to enter, and there is a possibility of taking a standard which are considered. So I believe that definitely. If you're interested, maybe I can spend some time only tomorrow. So I believe the Standards Association has a register of the standard approved in 5G, which can be interesting for these purposes. Also, in the domain of standards, I believe we have to notice something. The focus is more on the application layer, but on very demanding immersive applications. So also this standard can be related in the sense that they show what are the requirements for 5G. I think it can be interesting to integrate.
Yeah.
As a video, if you wish, I can say something about it. The activities and overall.
Yeah, thank you. That would be great. Yeah.
Thank you. We have a question from Mattia. Comment?
Yes, can you hear me?
Sure, perfect. Thank you.
Yep. Hi, everybody. So, one name that I haven't seen in this presentation and might be relevant is the Oran Alliance. I don't know if people here are aware of that. It's definitely more on the lower layers, but I'm not an expert myself. I'm just starting to study that, and that's where it came to my mind that it could be useful also for this project. It's basically a group they're basically trying to open the RAN, so the radio access network, and to split it into multiple components and add some intelligence into the network. So they have near real-time and non-real-time orchestration applications. The interfaces are open, so basically they are standardizing a way to get information from the network and bring it up to the upper layers, to the orchestrators. Some intelligence can be injected by means of machine learning, AI, or whatever, and they can reconfigure the network based on inputs from these orchestrators, both in near real time, meaning below 1 second or even down to tens of milliseconds, but also in non-real time, so for longer time spans. I think I've seen some QoE sprinkled around some of those documents from this Oran Alliance. But again, I'm not an expert myself. Just wanted to point out that maybe that could be of interest to you guys, because it's basically what you're doing. It could be a nice interface where to get information and also where to inject changes to the network directly.
Thank you. Could you write the group in the chat, please?
Yeah, it's Oran, I guess. The open
RAN. I didn't hear it. Open RAN.
Oh, the open RAN.
I guess. Yeah. Okay.
Okay, thank you, Mattia. If you come across any Oran, I haven't actually checked. I mean, I know Open RAN, but I haven't actually go into details. So if you have any pointer or where we find QoE related documentation, that would be very helpful. Otherwise, I will try to ask other people. I will eventually.
Sure, I will ask around. I've seen some collaborations also with universities that they were talking about some X apps, so near real-time application for the control of the network, and QoE came up into that. So I can look if there's something public on that, or if there is some demo. I think I've also seen something from MWC maybe this year or last year related to QoE and Oran. So yeah. I will try to look into that and give some pointers if I find something.
Thanks a lot, Mattia. Thanks a lot. Great. So if there are no more comments or questions, thanks a lot for your contributions. We will complete the material. It will be a nice starting point for the future. We can go for the break now. We might shorten it so that we catch up a bit. So maybe 15 minutes should be okay.
Yeah, that's fine. Yeah.
So we can break for 15 minutes. We start at 30. 40, let's say, 440. Okay, so we gain, it's a bit.
Yeah.
Back to the room, and I will, basically, so we have now this second part of the session. Well, yeah, so basically we'll have two presentations from industry, one from Francois from Meta and the other one from Emmy from AT&T. And then the discussion part. If you have kind of direct questions regarding the presentation, feel free to ask. If there are like more open ideas, hold them for the discussion, and then we probably can put, you know, all the discussion together. So the idea is that we can listen to both presentations now, and then go on. I don't know. Can you call them, because maybe they're not aware that you're starting? And I guess that will be interesting people. Yeah, just. Yeah. Meeting, sorry.
Wait 30 seconds.
Okay, I think we're gonna start. Or wait, it's up to you.
Okay, well, let's start. Good day, everyone. Good morning, good evening. My name is François Blouin. I'm from Meta, and I created that presentations with the help of two of my colleagues, Michel Ouellet and Ioannis, that is an active contributor. So the purpose of the presentation today is, as we've heard before, the quality of experience is an end-to-end optimization from a system perspective, and the big question now is from the CAPS, if you don't own a section of the delivery ecosystem, what do you do about that? Do you ignore it? Do you adapt to it? And what if we were to start exchanging information? As a content provider, we do have access to our content cloud servers and processing. We have access to the phones, mostly mobile phones, that with the applications are rendering there. But we don't have the piece in between where our customers will connect to an ISP provider, a communications provider, a Wi-Fi network. So the purpose of the discussion today is just share what are the metrics that we collect as a content providers that could be potentially exchanged, and what are the metrics we don't have visibility that we might want to have access, and try to basically deliver a better experience to our customers and also more efficiently. So in terms of why we're discussing that, as we heard earlier, there is a lack of cross-industry language definitions of what are the metrics, what are the targets, and how do we measure them. We also want to expand and explore potential collaborations between the QoE field and the QoS fields, or the CAPS and the CSPs. And at the end of the day is to improve the overall experience for our customers. So the deliverables that we'd like to explore today are essentially what kind of metrics we can exchange, how does it look like, and what are the actions that could be taken if this collaboration exists, and if some aspect of visibility in those metrics is shared. So quickly, I think Michele covered that in his presentation. Quality of experience, mostly at the end user level. This is what our customers are feeling, what are their impressions and appreciation of the service. And QoS at the network, typically infrastructure layer. Definitions, good work has been done by the Qualinet organization a few years ago that separate these two domains very, very, very precisely. This is a long list of some of the most important influencing factors that one could think about in building those QE models. The challenge now is, the list is long, and we organize them into three main category. On the left side, more the human aspect, which would be like more the demographics, some of the cognitive aspect of our brain, our visual system, our audio system, how this perception is taking place. The middle part is the system related, and that would have to do with the devices you use, the infrastructure that you use to transfer the information. And on the right side, on the context, sometimes we don't, maybe we forget, but if I'm using an application or a service on my mobile phone, my expectations are typically different than when I'm at home on a gigabit fiber network. So we need to pay attention to the context. Now, as we build those QE models, parametric models or trained models, it's very difficult to include all of those characteristics here. So we need to be careful about the type of services, again, the context, how we're going to be delivering them. So it's a bit of an art to select which one. Fortunately, there has been lots of good work from ITU and other organizations to provide us some, I guess, some recommendations on standards. And I'm showing here, I picked up 4 different classes of applications, starting with the voice, going to video, gaming, and XR, VR, 3D. One thing to notice as you go down on that list on the immersive applications, 3D, etc., you can see the list of influencing factors that I've selected is growing. So it's more complex to assess would it be good. So there are complexity in delivering, complexity in evaluating. So I'm sharing that here as these are kind of metrics that are important to pay attention as we start exchanging information. There is an aspect that I'll be covering later on the video front. I'm going to be talking about short form videos. These are videos that are short in nature, as the name says, maybe 10, 20, 30 seconds video. And interestingly enough, we're finding from our customers that video quality is important, but there is another important factor that I refer to timeliness. When I swipe my video, is my video appearing immediately or I see a spinning wheel? So now we're combining interactivity into fidelity of video that is becoming important. We'll talk about it later. So as I said, QoE has to be managed end to end. And this graph is showing who are the actors in the ecosystems that are controlling the different aspects. What are the typical impairments that you might see at the QoS level? What are the factors that we need to pay attention? And the blue bubbles represent mostly what the content providers have some level of control, mostly at the content generation or content serving side on our cloud-based systems. Also on the end user, the devices. The middle part is the one that I'll be talking more on the CSP side. It's mostly the operators, internet service providers who have that piece. So in the ideal world, if we want to have this ecosystem to deliver the best experience, these 3 segments needs to be orchestrated, or at least some level of knowledge. Alternatively, we can make our applications to adapt to the network variations, which we do, but there might be some benefits of having some level of visibility in the middle part to be proactively or faster making the choices of codec, the choices of bit rates, the convergence of bandwidth estimator that we have built in our product. This is an example of what I was referring earlier on the short form video, where the metrics here that we are collecting, and I put timeliness at the top because, as I said, it's becoming a very sensitive factor to reduce the annoyance or dissatisfaction if our users are waiting too long. Of course, the temporal quality, the video audio quality is important. So these are the metrics that we collect. And in more detail here, sorry, not more. So the challenges now that we have in delivering the video quality is the lack of a commonly accepted QE metric. So we among the CAPs ourselves, and also in exchanging this information to the telecom providers, how do we make that better, smoother? How do we ensure that that aspect of timeliness is factored in? Some models exist today, but generally they focus mostly on the fidelity, the video quality, which is great. But having a kind of a composite metric that also incorporate these timeliness aspect would be great. So in order for us to exchange this, we can look at a no reference metric would be better. A full reference metric would be tricky because having the full reference mean for the operators, it would be difficult to get access to the source material. So developing a commonly accepted no reference metric, and I'm glad to see that BQEG is engaging in that and ITU. So that would be, I think, an asset to have, and going to standardization thereafter would be probably a path forward. As I said, there are different ways to evaluate the video quality. This is the expert group. So the ones which I think needs a bit more, I guess, industry effort is on mostly the no reference, which I think are, there have been some attempt to do no reference video models, but I don't think there has been a well adopted ones that can be used at both at the content application providers as well as the communication service providers. And I'm citing here a couple of reference examples of what we've seen, both from the industry standard and some academic research. And I'm trying to circle on the left side where you see the green portion is mostly looking at the video quality as we typically know. And on the right side is introducing some timeliness, interactivity aspect. And I don't think there has been lots of standardization work done there, but I think that would be one of the path forward as a long-term goal. So this is now back to the CAPS point of view. So what are the metrics that we collect, and what do we do with that? So on the left side on this chart, you see a number of metrics covering, again, the timeliness, the temporal, and the spatial video, and the context. So we have access to this. Internally, we have a number of metrics that we generate. And on the right side here is what are the actions that are potentially applicable for those metrics. So we can control the source video encode and the resolution, the bitrate, and the playback as well. We select also, we have bandwidth estimators, so we're estimating the bandwidth of the channel, and so to prevent us to send a higher bitrate in a network that is congested. But for us to acquire that bandwidth estimation, there is a bit of a time and sometimes a lag, and also dynamically adjusting that versus having a proactive signal sent to us might be the de-jitter and playback buffer on the devices is something that we control as well. And the volume of data traffic that we generate. These are some of the actionable control knobs that as a CAPS, and I'll invite other CAPS to chime in into their, if I've omitted anything that is relevant here. Moving towards, I'm talking now, this is the CSP metric, the communication service providers metrics, but from the view of the CAP. So this is what we think are collected, and I'm sure the AT&T team talking after me will probably correct me, but they have a better visibility, obviously, in the network layer of some aspect of bandwidth latency and queuing delay and packet loss, and that allows them to control the network loading, how much load there is in the network, if a particular region or particular cell is congested, Do they apply policy treatment to rate balance or rate limit some of the traffic? And QoS class of service to prioritize some of the service or traffics or so. So there is an interesting a set of metrics here that being visible or somehow accessible through some form of API that would be beneficial, again, as I said, to improve the convergence, improve the decision making of not sending higher bitrate traffic and coding network that might not be capable of supporting. So as a challenge, now we have the two sides that we're trying to have some visibility. So it would be again, how do we implement this kind of exchange of information? How do we make it in real time? What type of protocol? These are lots of questions that would this work for all networks type, or we should focus on scoping it to a specific type of network? So there's a number of open questions that will need to be answered. So how do we start? How do we start having this discussion, and what can we exchange? So I would start by, we need to agree as a community, start from the CAPS perspective on defining what is a common metric among the CAPS that we would like to use and potentially make visible. So I would start there. That metric, if it could be on a scale that is understood, well-defined, 0 to 100, for example, and understandable, and on a mobile device, preferably. So we will need to correlate that metric to some subjective testing. So probably an area where VQuake could help. Also, another question would be: is this metric generated on the fly? Who calculates that metric? Is it the CAPS that calculates it and share it, or we give the inputs to a model that the communication service provider can calculate themselves? So these are some open questions. Of course, the QE to QoS correlations, as Michele mentioned, it would be critical to understand what are the control knobs, what do they control, and so on. So this is, I think, the last slide. So I think what I would suggest, and we can discuss that in the workshop in the next hour, is make sure that we agree on a business motivation to take on this interesting challenge. Is it to deliver video more effectively, making sure that we're not, again, wasting traffic on a network that is not capable of delivery efficiency? Is it to improve the overall quality of experience from the customers? We need to agree on the scope. As I said, are we going to be looking at all types of networks, or we focus on one type to start with as a, probably need to list out those gaps. I mentioned a number, and I'm sure there will be others identified by the next presentation and the discussion later. Decide, are we going to look at the methodology of testing? Are we going to start looking at the metrics to be exchanged? How do we define those metrics? Are we going to publish in point number 4, or maybe a white paper to start, or for a formal journal publication? Where would VQuake best contribute on that? I can think about some form of testing. Metrics and Q models would be probably an area of strength. May want to create a working group to get us going. And last but not least, at some point, do a field trial or a lab experiment to develop that. So this is a short view of what, from a CAPS perspective, we would like to share, the type of metrics we have, and some of the potential way forward. So I'll pause here, and I look forward to this discussion later, and thanks for being here.